let's get straight to the reason for our being here. This is the IMSF webinar series for the month of July 2025. So let's go straight into welcoming all our guests. We have our facilitator, our guest speaker is here, Dr. Nwafo Gideon. He's always here anyway. We have is Dr. Salawa available? Is she online?
Yeah, I saw her online. She's online.
Great. I can see her. I can see her. Okay, so today we're going to be looking at the topic of putting a focus on rare earth elements and the exploration techniques for rare earth elements. Strategic mineral is a strategic. They are strategic minerals for the future. I think anyone that knows about the mineral industry knows that rare earth elements have a very key role to play in the world we live in today. They cut across every aspect of our lives, and we're going to be delving into that in detail with our guest speaker. So let's welcome Dr. Salawa to give us an opening remark.
Okay, I think she needs to unmute herself.
Hello, ma'am. Can you hear us, ma'am? I think I can't see her name again. Okay, yes.
Her name is there.
Okay. Thank you very much. It's happy to be with you once again after all my traveling. And I'm happy that I met you well.
Welcome back.
Yeah, thank you very much. You people are doing great. And I know from this topic, we're going to acquire a greater height. The topic is, we're all doing the same thing. What we've been doing is to make sure that the young ones benefit from the present mining activity that is ongoing, from the upstream down to the downstream aspect, which is very good for anybody that wants to be a mentor to mentees. Thank you very much, Mr. David. The Terra Mining. We are here to listen to your presentation and further make comments. Welcome you all our good people who wants to promote the mining through practical aspects, not just theoretical. We do it here and we make sure that we follow it up in the field. Welcome and thank you for being here with us. I'm Sidika Tulad, Doctor, Mineral Explorationist. Come.
Thank you, Ma. So it promises to be a good time. A time for us to have an interaction within ourselves. So please, if you have already prepared questions or if questions arise during the course of the speaker's presentation, please go ahead, write down your questions or send them into the chat box so that we'll take them. I'm also going to be asking the speakers some questions when the time comes so that we can have an interactive session. So today, we have our very own Dr. Nwafo C. Gideon. As most of us know him, some may not know him, but I think almost everyone that's part of IMSF has a good knowledge of who he is. He's a highly accomplished and result-driven professional with expertise in solid mineral exploration and mining. With over 17 years of experience, he has established himself as a leading figure in the industry, consistently delivering exceptional analysis and reports. His educational background includes BSc in geology, MSc in geophysics, and he also holds a PhD in mineral economics. That's a lot. His professional achievements, he is the chief coordinator of IMSEP. IMSEP is the initiative for advancement in mining, earth sciences, and environmental protection. That's the same initiative that is hosting this webinar series. NC Gideon leads this esteemed organization, working towards the advancement of mining practices, earth sciences, and environmental protection. Dr. Gideon serves as a director, head of geophysics of several companies like Terra Explorer. He's also the co-founder of TrepGeek company, founder of Mineral Mining's YouTube channel. Please, I would encourage us to, I think maybe someone can put up the link of that YouTube channel before we are done. So you can follow that channel. It's a channel where you get to learn a lot. Anything you need, if there's a topic that he has addressed there, you're definitely going to learn a lot from his experience. NC Gideon shares his wealth of knowledge and expertise through his YouTube channel, Mineral Mining, which boasts over 200 published videos on mineral exploration and field practices. He is a certified member of COMEG, the Council of Mining and Engineering Geologists. He's a registered member of the NMGS, Nigerian Mining and Geosciences Society. He's also certified in Minex borehole database, geologic modeling, Minex open design and reserve, open pit optimization. So let's give it up for Dr. Gideon Nwafo. He will be our presenter today. Dr. Gideon, you're welcome. The floor is handed over to you. Please do justice to the topic. Thank you.
Thank you very much, and I appreciate your wonderful introduction and your kind words. How you've just started this, I think, in the industry, I think you're one of the people I've actually seen that so liberal and serious about this business. You know, I think what we're doing doesn't mean that we don't have any other thing better to do. It doesn't mean that we're not supposed to be in the field of reading and all that, but we know, we've come to understand that we've suffered a lot in terms of gaps in knowledge, in capacity, and human resources in this industry. So what we are just doing is just a minute of what we could do. At least we can't do it all. We only offer our own quota, as the case may be. Time is one of the things that you can never regain. There will be a time we can't do what we're doing right now. But whatever we can do at this time, we have to do it, whether we are paid or we're not paid and all that. So we don't need motivation from anybody. I keep telling everyone that knows me, I don't require anybody's motivation. I motivate myself. You can join the queue if you're interested, So I know how we started all this, and I will know where we are and we know where we are going to. So that's what we're doing. So today we'll be actually looking at, I've seen this as one of the issues we have. This is one of the minerals, rare elements is one of the minerals that are very, very, it's not, the knowledge is not common. The chemistry is not something that is easy, it's complex. In terms of laboratory analysis, in terms of understanding it, in terms of actually even exploring for them. So today is like bringing a very clear analysis and data towards this, this particular minerals, group of mineral actually, so they are something that I think is very important for us to understand, and also looking at the economics part of it, so it is something that drives almost every technology we have right now. It is something that we can't do without if we actually want to join the queue in terms of future technology advancements. So we are trying to focus on the rare element today, elements and the exploration techniques as a strategic mineral for the future. The key objectives here is one, to ensure that we all understand the rare elements, as the case may be, and also emphasize the strategic significance of these minerals in the modern technology, and also understand the market dynamics, geological and the state-of-art exploration techniques that actually we've seen in the modern day time. And at the end of the day, the overall aim is to build among our young geoscientists, bring the awareness among the policymakers, the investors, and also how to identify these minerals. The prospect we have in Nigeria, some of the locations that are being suspected, and also to bring in any data available and assess the economic and environmental implication of developing these rare elements resources. And in all, we look at, this group of minerals. The case may be there are 17 of them. They are very critical, and the role they play in terms of advancement of technologies, and what actually drives the economics in the modern day time: the EV vehicles, the wind, the energy, the smartphones, defense systems, and also as a source of renewable energy. And also, we also look at how there have been a kind of a puzzle, will I say, a power play between different countries that are trying to control the supply of these minerals. And also look at the geology of it, because that's where everything starts. If we don't have the geology of this mineral understood, it will be very difficult for us to actually understand, how to explore them, get them, and also sell them. So at the end of the day, we also want to see some practical challenges that are associated with these rare elements. The practical challenges, which we know that these include the complex mineralogy and environmental issues that are actually associated with the extraction of these minerals. We will also emphasize the value addition. We know where our strength is as Nigeria, as a country. We understand what we can do and the way forward to sustaining these processes. So we'll also look at some possible case studies. We've done some few projects concerning this, and we can actually look at them also, and we'll see how we can give a final thought to it. Then, what are these rare elements? As we just said, they are grouped together because they have something in common. They are chemically similar elements that actually occur together in nature and often found, the same mineral deposits. We can't say they are really rare, but the issue here is that these rare elements are usually difficult to find in such a way that they are commercial or commercially viable to mine. Most of your exploration, you might find out that we see them in the minute, in a smaller quantities, in a small ppms, 1 ppm, 2 ppm, and all that. But when we are talking about commercial viability, we need something that could, be economically viable to mine. We have, because of that, the minerals also are grouped into categories of light and heavy ones. This category is the light rare element, the lanthanum. These ones are, like say, is more of common compared to the heavy ones. The lanthanum, the cerium, and all that. Then we have other heavy elements. These heavy ones are not as common as the light ones. I will show you why they actually grouped into heavy and into light. There are some characteristics that are actually associated with them. Now, even in terms of uses, these are the major uses that drive the economics of these minerals. The magnets the neodymium are very, very important in these productions. In terms of battery, they are also very important. The cerium, the nickel metal battery hydride batteries are very, very important in our modern day technology. And they also act as catalysts. And also phosphors. Most of us understand there are a lot of components that actually illuminate lights in most of our TV and like LEDs and other lasers. So these are actually the components actually produced from the rare elements. They also use in glass and ceramics, and also most importantly, this is why they are actually grouped as very, very strategic minerals in most countries. It's not in everywhere. The military and the aerospace, the advanced alloys, lasers are all components of these very important minerals. Now, going further, these are the four major countries that are actually global producers. China are number one, followed by US. And there have been a part also between these two countries in terms of controlling this, who produces it. And also Australia is also there, and Russia. These four countries are a kind of world powers, we understand. So if you control rare elements, you control a lot of technology. So recently there have been some issues of trade war between China and US. Recently, China has placed a lot of restrictions in supply and all that. And US also, in the other way, has actually intensified exploration and other strategies. Now, if you look at the common rare elements, which is the monazite, the bastosite, the xenotime, and alanites, these are the common ones. And we also understand that we have some of these ones here. Now, the typical host rocks that are actually giving rise to some of these are majorly the carbonatites. The monazite actually mainly the placer deposits that we can actually find. We also know that we have this in Nigeria. So these are the major ones. Then the essence of this in exploration, it's not because of any other thing, but because they are strategic. And once you have a short supply, in short, the heavy ones are very, very, very rare to actually get. So it's just because they are strategic in terms of green technologies and energy transition that we are clamoring for. And also, there are the limited global producers. This is very clear. Producing in such a way that is very limited. That we can see, mainly the four countries are the major people that are actually producing it. And again, producing it is not the only issue here. Another issue is processing it because of the complex chemistry of these rare elements. So another thing in terms of why they actually matter in exploration is, the high value exploration targets we should be looking at are these: the laterite, the carbonatite, the pegmatite, and some of the alkaline ring complexes, which we know will have some of this geology in Nigeria. So this is actually why they are divided in terms of abundance. That is why we divide them into the higher and the lower rare elements. The abundance, you can see, the heavy ones are lower. In terms of deposits types, mainly the light ones are actually mainly of carbonatite, monazite sands. When it comes to extraction, the light ones are easier to extract. And when it comes to economic value, then it's bulky to supply the light ones. But in terms of heavy ones are rare, and they're very critical in terms of when it comes to military hardwares. That is actually what is actually mainly used for military hardwares. That's why most of the countries that world power do not play with some heavy rare elements, because of the productions involving the military hardwares. So in terms of uses also, we can see mainly the light ones are mainly in batteries and magnets, while the heavy ones are mainly used for defense technologies, lasers, and some electronics. Another reasons why they actually, in terms of why they actually divided heavy and strong, is because of the bonds also. The heavy ones form a very strong bond with oxygen, and they tend to stay in a solid state, unlike the other light ones, you know. And also, these also how they are transported, and they are concentrated in different types. So in terms of the chemical bonds, they are not the same. And even in terms of mobility, you know, the light ones are even more mobile and easily concentrated in magmatic process, unlike the other one. So that's why you can easily detect the light rare elements. Even in your exploration in the weathering zones, you can easily be detected, unlike the heavy ones. Now, we want to look at the strategic importance. Why are they very important? And they're very indispensable to modern life and are critical to a transition toward a low carbon, because, you know, they can secure our future in terms of unique chemical and physical properties. You understand that these minerals are irreplaceable in many advanced technologies. So that's why we look at it as, if you can control the rare supply of rare elements, you can control the future technology. So we look at it at one as strategic important, at one being the backbone of the modern technologies, especially, you know, the neodymium and praseodymium are very, very used in terms of magnets for electric motors and wind turbines and other audio systems. So this is it. Then the second one is, you know, the enablers of green energy transition. In terms of this, you cannot, you know, if you are trying to transit from the fossil fuel to green energy, this is very important because of their critical importance in wind turbines and in energy storage systems, you know. So this is second one. Then another importance of rare elements is the vital nature of it in terms of national security and defense. You know, many of them are considered defense critical by U.S. Department of Defense and other global military agencies. They are also used in jet engines, guiding missiles, satellite systems, night vision gear, and radar. So you can understand that this is very, very important use. So their functionality and precision of many defense systems everything rely on these rare elements. Then another strategic importance is the digital and industrial innovations in terms of Internet of Things. They are actually required, highly required, you know. And also we look at they are very, very flexible in terms of manufacturing and industry. You know, when it comes to improving the efficiency and the sustainability of some of the traditional industrial tools, you know, like catalytic converters in automobiles, they are there. In terms of alloy making, in terms of glass and polishing, they are there. Another one here is, you know, the supply chain vulnerability and political leverage of this. You know, when you look at what China does, the kind of control China have over this, that's why you won't be surprised the kind of technology and the kind of advancement and the speed in which China produces a lot of things. You know, we also know that it's almost everything in Africa now, everything comes from China, everything. So because of this, US, also Japan, also declared all these minerals are very, very critical, and they are seeking a way of sourcing these to build domestic production capacity within their own countries. You know, so this makes it really, at least from main industrial minerals to just strategic assets when it comes to global power play and other dynamics. Another thing is that this can be an economic catalyst for Africa. The issue is that we need to understand how this could actually be developed in Africa. We have it in Africa, countries like Nigeria, Malawi, Brazil. Brazil are not coming, but they're actually coming up, have some of these opportunities. So if we can join other countries, even if in terms of exploration and supply, at least we can do some extent of beneficiation. For now, I'm not sure of value addition, but that is the way to go. any value addition that could be added to this in any part of Africa can significantly increase our contributions, to these great high-skilled jobs. So I think this is why I think the knowledge of these minerals has to be declared, has to make very, very critical to our young exploration geologists. Now, when we look at the supply chain and market dynamics of this mineral, you will understand that they are central to modern technology, and because of this, it's highly fragile, and also there are a lot of politics. This is politically sensitive. So the global market reveals that there is a lot of interplay between the resource availability, the processing, the demand, and a kind of political issues around it. But let me say, in terms of supply, there are 5 stages that one can actually look at here. Exploration and mining is the number one thing. If you don't explore it, you don't mine it, you don't extract it, there is no way. Then after you've mined, what the next thing is to concentrate and beneficiate. Just kind of crushing it and separating some other unwanted product physically from them. That is just, you can use that flotation, you can use gravity, you can use some other method of concentration to do that. But another one, which is the third one, is refining. In terms of refining and separation, this is where some issues are coming up. This is where that will require a lot of chemistry, a lot of metallurgy, a lot of other components for us to do. In short, let me tell you, I think that 3 to 4 is where few countries have industrial capacity. But I know as a country, we can start with 1 and 2, exploring, mining, concentrating, and beneficiation. At least we'll be able to concentrate it or beneficiate it to some extent. Then we can have a kind of a collaboration with other countries for other refining and separation. So looking at this, in terms of that supply, there have been a lot of key initiatives to diversify by different countries due to the risk of overdependence on China. So now a lot of countries are pushing to diversify sources and build independence of this supply. So I think it's something that now US has come up with a strategy of trying to be dependent internally. So I will say we cannot lose hope of this. In terms of Australia also, which is also part of the game. They've also joined. Canada has also been part of this in terms of manufacturing initiative and all that. Some other countries of Europe have also been part of this. So I think it's something that we need to also see as a future opportunity for us. Now, that is actually why you see US, India, Japan, Australia form a kind of alliance on these developments. So this rare element is a very critical thing that even our policymakers in the country will start looking at this. What is the way forward? Where do we have them? It is something we can start developing as of now. And in terms of the market demands, the market is there, is rare. The market is there, so the market is not an issue. When you're talking about the market, what drives these markets is the EVs, the energy, the wind turbines, the smartphones, electronics, and all these are not something that you can say that they can run out of, that in the nearest future that there won't be actually need for them. There won't be, in the nearest future, everybody is going to electric vehicles. Everybody wants energy that is stable and steady. Everybody, smartphones are there and they have come to stay. The defense, everyone wants to build a very stable defense. So because of this, there is actually a market volatility in this. So I will say that not only that, there are also some challenges involved in building a resilient global supply chain. Now, the challenges is not something we cannot overcome, but I believe that we need to start counting one first. When you look about the complex methodology of it, it's very clear that it is very, very complex. When you look at the ores that are required, and the separations that are actually involved. Also, in terms of the tailings, in terms of radioactive nature of it, like thorium and uranium, actually associated with these minerals, that is environmental concern that also need to be looked into. In terms of capital intensity, yes, it requires a high upfront investment and market entry barriers because of Chinese have developed a very long, low cost processing. It makes it difficult for most people to just come into the competition. So you need to build a lot of infrastructure, which is readily available in China. So almost infrastructure that are required for this, those guys have actually built it. So I think these are the challenges that every country needs to look into. So they need to address these challenges in terms of using some policy support, public-private partnership, and some investment to actually deal with this. Now, in terms of future outlook from this, monopoly of this, it is clear and it's expected that this is definitely going to grow significantly in the next 10 to 20 years, might even be more than double than what we're actually looking at, And also the supply diversity will intensify with different projects, new alliances, like the trade war that just triggered a lot of initiative from UX and some other alliances trying to, bridge the gap in terms of shortages in supply. So I think that the rare element is not just because of the industrial value, but another thing is who controls it. It's very important. Who controls it is very, very important because of what they're actually used for. Some countries might have it, they might not actually want to sell it out or actually give it out. So some developing countries like Nigeria, we are uniquely positioned to benefit, if we can develop this and integrate some sustainable supply chains. Like I said, we can. So let's just look at it as another alternative way. Okay, then this is to geologists. Now I'll briefly just look at the geology of this because this is very important to us, the geology and the occurrence of this. If you look at everything in the whole entire world that have produced more of this, it's actually from the carbonatites. The rare elements actually are dispersed in a very, very small concentration in most of the rock they actually found. The carbonatites actually is a kind of is a granitic rock that contains carbonates. They are rare. They are not common. They are not actually common. In most of the places, like in US, the Australia, and most of the places they are found, they actually contain more than 50% of carbonate minerals. So the carbonatite is a rock we need to find. They are rock we need to find. Their key characteristics mostly are containing the Ce, the La, the Nd, and the Pr. And they're also associated with alkaline magmatics and some of the rocks that are actually deep-seated. So I think it's something that we've suspected to be existing in some locations, so we need to give them a trial in Nigeria also. So a carbonatite is just one of the host rocks that are actually known worldwide to have a very strong control for this. Now, I've tried to look at some of the locations that these have been suspected to occur in Nigeria. The Toro Alkaline Complex, the Toro Bauchi area, which we know located in northeastern, is another place we can look at this. The Kaba Okene area also is another location that we are suspecting that we can get these kind of rocks. The Igara also area and also the Jos Plateau. We understand some of the ring complexes in Jos Plateau exhibit some geochemical signatures of some carbonatites, affinity, and these have actually been mentioned in some literatures and some works of NGSA. And also we think that not also this, most of some magnetic processing and some of the interpretation we've done has shown some possible anomalies that need to be checked in terms of, ring complexes of Jos Plateau, and some other locations, which is unconfirmed, definitely a Sokoto area. So we need to look at these locations. Another geology of this is the alkaline igneous complexes. These are systems that are actually enriched with the potassium and sodium and very, very low in alumina. So we can look at this igneous rock, and this is also usually enriched with heavy rare elements. These are another geology. Another one is some clays. Some of these can actually be found from weathering of, some of these humid tropical environments. Like in some laterite, most of the time, you see that some laterite, when you test them, they can give you a very strong clue of different elements that you cannot even only see in some rocks. They can easily be seen in such an environment. Another one is in terms of, we know that a lot of people have actually mined the monazite from the secondary deposit by weathering, and some concentrations from alluvial kind of work, especially in the plateau areas. So this is another area we can actually get this. They actually formed in some monazite and xenotite placer deposits. So with this, I think why we usually found ourselves, or most Africans, in this is because these are easily exploited, they are easily explored, just the mineral sands. They are easily explored. That's why you see us mostly working in the alluvials. But the rocks, sources of these minerals, should be another interest we have to look up to. Yeah, they might not easily be found, but I think there are a lot of possibilities and the geology to support that. Now, coming to the techniques that involve or required, we can say that number one thing, if we are looking for this, is it requires a unique exploration. And we also understand the challenges due to their complex geochemistry, the mineralogy, and the widespread low concentration distribution of these rare elements. So have one, you need specialized knowledge of this. If you don't know about this mineral, how do you actually explore them? So that's the reason why we've made it very important that we bring about this, so that we will start looking at way out of it. You require high-resolution tools like remote sensing, some magnetics, some radiometrics, and other processing tools that will be required. Definitely, going into it, you need to understand a lot of things to generate your targets. If you've not done a data compilation from different sources and databases and occurrences, so from airborne geophysics, and all that prior to it, you won't be able to get your target. So it is very important that you focus on your desktop studies and focus on identifying where there are possible carbonatites, the alkaline complexes, all these zones that will play a kind of placer-rich terrains, So all these desktop studies are utilizing all this remote sensing. Is very important for you to identify, where this is actually going to be happening. Now, in terms of remote sensing and geophysics, I will say that it is very important. The use of radiometrics is very important because of the detection of potassium, uranium, and thorium. The combination and ratio of these and the accounts will tell you possible locations where this can actually occur. Then magnetic gravity surveys are also very important, and some hyperspectral imaging systems like ASTARs are very important in terms of this. Now, if you look at this data is a part of a project that we did in Nasarawa State. If you look at this is just a magnetic data, electromagnetic data that was actually processed, and a lot of things we actually combined with this before we moved into the field to look at some of these targets. So it is very, very important that you deploy, high magnetic data and obtain some targets and anomalies in some locations, combined with some other geochemistry before one can actually move into this. Because interpreting these magnetic anomalies, some high-intensity circular anomalies can give you some clue of a possible alkaline complex. Some magnetic boundaries can show you some contact dikes or ring fractures. Some magnetic loads surrounded by some heights is also can tell you about weathered locations or cores that are actually surrounded by magnetic zones. Some lineaments intersecting circular anomalies, is also a structural control that you can also pinpoint at an important target. So this is the reason why you should bring this into that. Then if you are looking at the aeroradiometric data also, some aeroradiometric data are very important when you combine the thorium, uranium, potassium, all that, because we understand that these measure the natural gamma radiations that are actually emitted from the edge surfaces, primarily from the decay of these three elements. So their combination is very, very important. So I will recommend, based on what we've actually done before, and that focus on these aeromagnetic anomalies that concern with some ring structures or alkaline intrusive bodies. Then you have to look at some areas that have some high anomalies plus low K, high uranium anomalies with some pegmatic zones, and areas of non-fluvial monocytes also, concentrations. So these are some of the clues that could help you, understand where you can actually use as a target, Then another one is some geochemical survey is another interesting tool, coming up with soil sampling, in a very systematic grid. You can't do anything more than 100 by 25 or 200 by 25 or 200 by 50. This is at least will help you. This is the first tool that can help you if you are doing ground truthing for this kind of exploration. It will help you to detect surface enrichments. And from the surface enrichment, you can now narrow down, go deeper into what you're actually looking for. At least focus on some of these elements: the cerium, the lanthanum, the neodymium and porosmidium, the yttrium, the thorium, and all that. Phosphorus is very important because, the rare elements are very high with that. Then the stream sampling is also there, maybe in a very rugged terrain, for you to understand if there are highs and lows of that. So, and another one is, definitely, generally in terms of geochemical, focus on the soil, focus on the soil, and sediments, on the rocks, and also you start looking at some pathfinder elements that are very, very important in terms of ratios. You can combine different ratios of pathfinder elements. We treated this before. Then, in terms of interpreting this, I would say that portable XRF is handy and common before possibly you can go into some ICP-MS and ICP-OAS, because there are some modern portable XRF that are equipped with vacuum that can detect the rare elements, So if this actually used, what you need to do is to look at some signatures. The signatures, like you can see here, I will show you what we did. We use these signatures, to detect some places that we think that are anomalies, and we're narrowing down there the combinations of thorium, yttrium, niobium, and phosphorus. This can suggest some monazite rich zones. And you can look at the signatures I've actually mentioned here. You can use these signatures to look at some possible locations that might be interesting to you, So, and also understand that using some XRF entails some best practices you need to follow up. So if you don't follow them up, you might mix up your data. You might get some readings. So using XRF, you need to pay some particular attention to calibrations. You need to pay attention to how the samples are actually prepared. And at the end of the day, you can combine some of these things with your radiometric, magnetic, and some high spectral images that you've actually processed. So that is it. Then, that is it. That is in terms of portable analytical tools. If you have your gamma ray spectrometers, these are very okay. You can grid your field and you can easily detect natural radioactive elements, in the field in terms of your thorium, uranium, and potassium. So also some of the modern, like I've said, are very useful in mapping. So these are some areas. Okay, look at this. This data, this is actually work we presently going on now. We've been on this for over a year and plus now. This is the anomalies we've actually detected here. You can see the anomaly map. These areas are areas we think we are going to going in deep. This was actually a soil work that was graded in 100 by 25. So you can see the resolution is very high. No, 100 by 25. Resolution here is very, very high. So at the end of the day, we've been able to get some locations where we are going to focus on. Now let's look at the last one, which is definitely when you've done your 1, 2, 3, 4, you can now want to obtain, a very deeper kind of data. A deeper data in the sense that you need to confirm a vertical continuity, degrade the depth by core drilling. This is one of the most expensive part of the entire exploration. You can do that. You can do the core drilling. You can do the other kind of drilling, destructive kind of drilling, and all that. We can also do your trenching, your pitting definitely does need to come in before this going down. So core drilling is like if you've done a lot of things to understand that, yes, this is definitely there. But in terms of commercial viability, the grade actually or the quality you have is not the same thing as quantity. So, but this will give you both the grade, the quality, and quantity. Then some other extra things need to be done after that is in terms of your petrographic work, XRD, and some analysis that will require beneficiation testing. At this is actually required after your drilling. At this stage, that you are going in for a business. Before you get to this stage in terms of exploration, that means from step 1 to 6 actually marked. Okay, I don't think that you'll be talking about beneficiation testing, if you've not understood the commercial viability of the mineral. Then we try to look at the effectiveness of all these methods. Clearly, the soil geochem, these are the major methods here: the soil geochem, the geophysics, the petrography, and the drilling. You understand the effectiveness of this. You can see that just geochem, apart from drilling, which that is the last confirmation. soil geochem is actually very important, and the effectiveness is very high, followed by geophysics. Petrography is list of them. So two things that definitely need to be combined if you need to find this mineral is the geophysics and the soil geochem. These are two things that must go. Now, looking at this, why it's very important we explore for this is that these minerals are very costly. You know, they are very costly, and it's something that a small amount found can pay for the expenses. If you look at this, you can see the cost of this. This is current price this year. You can see, and you can look at the terbium, look at the oxides, and you can look at the costliest one, the scandium. You know, some of the heavy ones are very costly, as you can see. You know, 3,787 per kg. You can see the neodymium, which is actually mainly used in the magnets of some of the vehicles and some equipment. You can see the price $68 to $70, $69, $70. So these are some of the sources of these. So looking at this, it can pay if it's actually found. So we better look at this. So like I've just said, what it means for us is in exploration, looking at the prices is for us to actually go in for it. You know, we need to go in for it knowing that it's going to pay. You know, it's very strategic, and there are a lot of opportunities in this. Now, what is the key takeaway from this? You know, the key takeaway from this market is, you know, it's very straightforward. Okay. Now, we'll look at the medium heavy rare elements. These are actually both scarce and also valuable. So we need to look for this. Definitely, they are going to justify any kind of exploration if they are found, you know. And also the NDDPR oxides are majorly used in magnet production, you know, with a very, very robust global demand. So we have to look at them. This scandium is very, very costly, and they are very lucrative, you know. Then also the market shifts, you know, like China exports. Definitely they are controlling the way they actually take away these minerals. So because of this, the minerals prices are actually going up, and definitely this actually giving a new phase for some countries to go into exploration and supply of this mineral. The processing techniques is like every other, but where the issues are is in terms of separation. Separation of these minerals involves a lot of, you know, involves some complex stages, multi-stages of chemistry, mineralogy, metallurgy, and engineering. So it's not just what you can separate like every other mineral, but it has its basic stages in terms of when it's mined, physically we can actually separate them, you know, concentrate them, you know, but the next stage becomes breaking these mineral bonds, which will require high energy. And after you've breaking them, the next thing will be leaching them out using some solvents and some chemicals to actually extract them into solution. And you now, after extracting them, leaching them out, you look at purification. And the last stage, which is not something that you see in every country, is metallization and fabrication. That is putting these minerals, you know, these components into different kind of products. You know, this is where the value comes in. But most countries, I think China is the only country that is like, they do all the whole stages from stage 1 to final. Some other countries actually, they have an ally, build their plants in different, you know, they have the kind of alliance, you know, coming together to make this work. But my crusade is that we need to start, at least we need to find ourselves in the first and the second stage as a country. So the real key areas of focus for us in terms of developing this is in geological exploration and resource evaluation. What do we have? Where do we have them? Do we have the data to attract investors? Do we have the data to actually mine? Another thing is we need to focus on laboratory and analytical upgrading our laboratories, the government laboratories, the individual laboratories, welcoming what we have. Another one is in terms of policy and the regulatory framework, establish something specific policy that are incentives to attract investment as regard to REE developments. Then we'll also look at the processing and value addition, at least like I just said, local beneficiation and these separations. Technologies can also be actually enhanced value addition in our own country. And we also need to focus on capacity building, developing skills, awareness. It's just like what we are doing right now, and also focus on understand that these tailings of these minerals have some environmental and social issues. So we should also understand how to build environmental and social governance to create a sustainable and mining practices within the country. Then we focus on strategic partnership. We can never do it alone. We have to leverage on some other international collaborations and technologies to develop what we have. Then we have to understand how to stimulate local industries that actually uses this, to be able to drive down the downstream integration. Then I would say, finally, that the future belongs to us. Definitely, we need to explore this responsibly, innovative continually, and we invest in strategic resources like this, not just looking for lithium alone, because we understand that lithium, most of the mineral that we are looking for, like the pegmatites, we are only looking, they are talking about lithium, but most of the pegmatites that consume lithium have a very strong tendencies to contain the rare elements. So we shall also focus on that. So in concluding, I will say, one, we have to understand that these are indispensable to modern technology. We need to understand their geology and their occurrences within our space. We need to understand their exploration techniques for us to actually be able to explore them. We need to understand how we can add value, at least within the first and the second stage, and locally process them. Then with this, we have to understand how we can now build some policies that are particularly, addressing the issues of rare elements. Sustainable practices and policy frameworks have to guide the development of these projects to minimize the environmental issues. So references, you can actually get some of the materials from USGX, some works of NGSA and all that. So I say from there, I will thank you, and I will wait for your reactions, contributions, and the way forward based on what we've just discussed today. So I thank you all for actually coming around on this. And David, I'll hand over to you. Thank you.
Thank you so much, Dr. Gideon. Thank you so much. I believe everyone here has been listening attentively. The REEs have been, they've been something so many people have been hearing. Very, very little is known about it. And this is a key area where we need to wake up before we are overtaken by foreigners. I wanted to ask a question, what makes it strategic? But I think from the presentation, you've answered that question. For us to have certain kinds of minerals that have value, very strategic and key value in practically every area of life, in medicine, in defense, in whatever, in the automobile industry, You're finding them everywhere. And we're beginning to find pockets of deposits in Nigeria. So it's very key. So please, if you have questions, please package your questions. You can raise your hand if you have questions to ask, or send them in the group. Meanwhile, I will ask one or two questions for you, Dr. Gideon. So one of the things that is important in all this, in all the expose that you've given to us as regarding the rare earth elements, one of the things I was just thinking of is, how can Nigeria, how can we, because these minerals are not called strategic for any reason. Even governments use them to negotiate trade deals.
Exactly.
I remember listening to the news of how Trump practically muzzled Ukraine. If you want us to assist you with the Russian war, you need to sign the mineral deal. And that mineral deal is for supply of what? Rare earth elements.
Yep.
Because we know the largest manufacturer of anything defense in this world is in the United States. So you know that China is already holding them at the jugular with that, because China is the largest producer of REEs. So I would ask, because we need Nigeria to come into that equation, at least in Africa or in West Africa first, Africa, and then hopefully in the world. What's the current state of RE exploration in Nigeria or West Africa? That's question one. Question two, how can countries like Nigeria strategically position themselves to become key players in the RE value chain? So this is important because these are the areas where geologists will find value. These are the areas where geologists will find use. The country will gain more economic benefits, and the industry develops overall. So if you can quickly answer those questions, just give us a run through.
Okay. Like I said, first thing first, there is no way we can actually make any meaningful impact in terms of putting ourselves within the global map without having to do the first thing first. That's why I said, how do we come in? We can only come in first by understanding what we have. Is there anything like that? Where are the locations of suspected digs? What is the exploration strategy? What is the policy behind this exploration strategy? There are some minerals that the government needs to actually declare state of emergency. You understand? In the sense that these are strategic. We need to find this. How do we get this? Where do we get them? You understand? Like you said, the mineral deal. The mineral deal, they didn't go there to go and sign a limestone and coal. These guys understand that for you to control the world and all that, you cannot build your weapons, you cannot defend your airspace, you can't build aircrafts. These are the things that, it's not by building. Yeah, we can be here building bridges and building roads, and all these things are not the. Any country can actually threaten you and all that. Apart from developing whatever you have, if you are loose in terms of military, you don't have the power, you cannot defend the lives and the property of your people, you've not got any technology. You understand? So when I've looked at this, I said, wow, this is actually why this mineral is, there are a lot of politics in it. But a country itself, is there even awareness? The government, do they understand the strategic nature of this mineral? Do they understand that we are giving our lithium, everybody talking about lithium. How many people understand that what we call REEs? The lithium we are giving away, how many of us understand how much of these REEs are contained in the lithium? You understand? Because you only go to lab, you take the lithium percentage, 2%, 3%, that's all. Nobody knows the amount of lithium or ND or scandium or anything involved in it. Meanwhile, these minerals are called together. So that's why I said, you see what I said, that some areas that we need to work on first is first in geology, exploration, data gathering. And secondly, in terms of building our labs, upgrading it to understand that if you want to, okay, you want to test this, where do you test it? Nothing, you cannot test it anywhere here. By the time you go to Australia to test it, you are tired. You cannot even try it. You know, I sent a sample to Australia. It took about 4 weeks. You understand? 4 weeks after for it to come out and all the whole process and all that. Then if you now look at when it gets there and all that, it gets into 6, 8 weeks. You get it? So the issue is we need to start the small ones we can do first. We'll talk about processing, because we'll be talking about processing of them. The only thing we can do is just physical separation and beneficiation using a kind of a gravitational method and all that. But we can't go into the leaching, cracking, and the kind of trying to separate all various kind of metals into the various elements. We can't do that now. But I think that we need to declare, when you say awareness, our policymakers, our regulators, our government, are they aware how strategic are these minerals? Have they asked the questions? Have they called the professionals? Where are these minerals? Do we have them? What can we do? How can we find where they are? What are the regulations around them? Can we say this mineral can be strategically explored like this? Can we, there should be a framework. There should be a framework towards this. If not, they will still come in, look at this mineral. They will take it in the form of lithium away. Yes. Well, they don't know what they are taking. But it's we don't even know. Do you know that before lithium have been thrown away?
Yes.
When they are mining, people are looking for the other gemstones. They throw out. Yes, it's recently that they even in Nasarawa, when the guy told me that for years they've been throwing away these rocks.
Yes,
so the awareness is very, very important. So if we don't understand the awareness, there is no way we could even go anywhere. So I think that the summary is that we need to start from the geology, the exploration, and understanding this. Yes. Whatever any geology is going to do, remember, if you don't have a good lab that is upgraded to this, because it's only when government is aware they will be asking, okay, what is required to even test these minerals? How can we equip our agencies to have ability and capacity to test it? It's the only way you can find them. There is no rock you see now. You see this contain this or contain that. It's impossible for you to do that. These are something that occur in a very low concentration. They are not like every other mineral that you can, once you see them, you know that this is the mineral.
Yes, thank you. What you just said is a common thing in Nigeria. I remember hearing about long ago how the Chinese love Nigerians lead, and people think, oh, it's just Nigerian lead. But later we found out that they love Nigerian lead not because of the lead, but because most of the lead is with silver.
The gold and the silver.
Come with silver, comes with gold.
And come with copper. And
the small
silver
it's more valuable than the lead that they are mining out. Dr. Salau's hand is up. Mark, go ahead with your question, please.
Thank you very much. A beautiful presentation in line with the economic value of our mineral resources today. Yes, little is known about the low rare earth element and the hard one. We have it. It's been on and on and on. We've worked on it. But we never knew the importance of it. Every time our government say we don't have enough, yet we work on enough of these minerals day in, day out, without knowing. What we are doing now is advocacy for knowing our minerals resources, especially the strategic and critical ones. And there's this scam on all these minerals. that has been since even when I started studying geology. It's capital intensive, capital intensive, capital intensive. And yet, out of this capital intensiveness, that is where some people came in with slippers and went back with an helicopter. Why can't we too start thinking of something? Let's start small and grow big, so that all this thing that is scaring us from touching our resources will no longer be there. I don't know if I'm making sense at all from what I'm saying. So in the market gaps you are talking about, if you start from 2 CUs today, and the people that are knowing what it contains are come around to partner with us, do you know we will grow to 30, 40 CUs in the following years? And that is when our own capital will now come in. We'll now be able to strategize our exploration and exploitation. And once they know that what we are having is what they are in demand of, then we grow. Enough of loan, grant. Where have you seen your enemy empowering you to be stronger in any circumstances? Can your enemy, we identify this thing that these people want to take all our resources without paying. Then you now say, please give me money so that I can empower myself, so that subsequently you will buy it off me. It's not going to happen. Even when all the one they are doing now is just a token. The only thing that God bless us with so many things, that even if they continue to take it in the next 100 years, we still be on. But meanwhile, let's benefit from whatever we are having that we call resources. And the only way we could do it is making sure that we know what we have, because when you don't know what you have, everything will be sand. Just like my custom people have been allowing in Chinese to export sand since the last 10 to 20 years ago, or just sand. When they get to the port, they say it's sand and they allow them to pass. They have forgotten that close to the ocean there are sand, but they are not packing those sands. They have to go to Zamfara to pack sand. And
Yes,
and export. So sand the grassroots studies, the grassroots awareness campaign should come on board. Let our people not be so greedy. You will still make more. Just allow this awareness to go around. By so doing, if we have like young miners club, just like we have young farmers club in all the local government area of Nigeria, that is comprising about 774 local governments, we will get something out of it. And then people that will come, we have to meet with the indigenous people before going into their lands. Not just anybody flying into my land and going with everything. Then we are now crying every time. This is this, this is that. We allowed it. So, Mr. Davids, yes, Dr. Onwako, you are doing a great job for the young ones. And I pray and hope that it continues. Don't get tired. Although they always say that the reward of teachers are in heaven. That was then, no longer now.
No, we are not part of that. We are not part of that group. David.
The reward
our reward is now. We are not part of that. Yes.
And the Lord will help you.
Yes. Amen. Yes. Thank you, ma. Thank you, ma. Okay.
Thank you so much, ma. It's important to note that IMSF's webinar series is part of the awareness campaign
Okay.
that is assisting in
I'm in a meeting. I will call you back. I'll call you back. I'm in a meeting.
Assisting professionals to, you know, be more aware of these things. If you didn't know anything about REEs now, you have a reasonable information that has been given to you. From here, this spurs us on to go and investigate more. Use this for your thesis. Use this for several things. When you hear about it, and you test it more in your samples. You won't just take samples for gold. Test for other things. Recently I have a client in Kwara State who were doing some work for him. And he called me and said, he wants to send the sand from the alluvial site. And he sent the sand to Zeconex lab. Zeconex tested it, and they discovered that there were REEs there. So it's gold they are mining, but there's alluvial deposit of REEs there. Now the conversation has changed from just gold mining to something else. I think someone posted in the chat said some of our lepidolites are having rhodium, which is more expensive than the lithium itself. So it's important that we professionals know. If you don't know, ask others that know. They will assist you. When you are running tests, run for more than just what you're interested in. Run a multi-element test and see. Study far and wide so that you can understand the things that are likely going to come up in the areas of your study. Let's go to another question. Esther Chinwoba. If you can hear me, please unmute yourself and ask your question. I will take a few more questions.
Okay, good day. Good day, Dr. Gideon. Good day, everyone.
Good day,
can you hear me?
Yes,
we can hear you.
Okay, this is a thought-provoking presentation and an eye-opener. Sir, from the beginning of your presentation, you made mention of rare earth elements being found in the laterites. But going further, you did not dwell on it. So my question is, can rare earth elements be found in laterites, or further exploration needs to be done to ascertain that possibility? Thank you.
Okay, nice one. The most important thing you should know is that the laterites are within the weathering zones. Laterite is a part of the earth that will give you clue to almost everything you are looking for when you come to any environment, because they are the weathered products from the main sources, especially in the tropical regions. So if you are looking for gold, for example, there are some lateritic crusts that gives you high, they give you, if you are looking for, like what we did last time, we're looking for gold. Where did we obtain our arsenic? Everything was gotten from laterite. So the laterite that gave us clue to what we are looking for. You understand? So that's why you pay very strong attention. You don't just that they're going, maybe this laterite. They're like, what most geologists will tell you that it's everywhere. Now this rock is everywhere. No, all laterite. These are the rocks that definitely gives you everything about that particular environment. In short, once you test it, you see the element. When I went to the last work we did somewhere in medicine, how did we start exploring for tantalite? It's just because we saw some elevated numbers of it in a laterite. You understand? So don't fail to sample your lateritic crust and your laterite. Don't fail to do that. You understand? So when you fail to do that, you are saying you want to, in short, when you are sampling your soil, you don't sample the black soil, do you? You don't. You go to the saprotic level, the layers that have been welded, oxidized zones. These are zones that gives you the clue of what you are looking for. So that's why I say that they are very important. You find them there, So you, in every environment, especially in a granitic environment, you're in metamorphic environment, you see your lateritic crust, which you can see that they occur both in all the environments. But depending on the geology where you are working for, they are very strong clue to the mineral exploration. I'm seeing Jacob's hands too up.
Yes, Jacob Obarizu, please go on with your question. Thank you, Esther.
Thank you so much for the presentation, which is an eye-opener to these important minerals. My question is based on security issues. Example, in my place here in Hamufu, we've been hearing about the security issues happening around there. I overheard when one of the hosts made a statement, you should know the place of its occurrence, or where, even though I don't know, but the rumoring that there's something so important happening around where this insecurity is being prominent within my place. My question is, how can one be able to, have access to that kind of locations? Maybe take soil sample or things to analyze. What's the possibility, of getting close to such kind of an area?
What do you mean? I mean, you mean that in a location where you have security issues?
Yes. For instance, in my place in Hamufu currently, there's a place where
Hamufu State.
Yes, these Fulani militants are disturbing around. People don't now go towards there. And from what I get from locals, they were saying there are some things they are seeing around the soils there over some time ago. So I don't know whether it's because of that. And again, we used to see some helicopter that will go through towards that directions, and sometimes return, and before you know it, they start having insecurity issues.
What state are you talking about?
I'm talking about Enugu. Now, my question is, if someone wants to get soil sample towards that kind of area to find out to know whether you can see something of that nature, because from rumor, we're saying there's a mineral deposit somewhere there. Maybe that's the reason why they're having such kind of issues there. So what's the possibility of somebody going towards that kind of place, getting soil sample analyzed to find out whether is it because of this REE deposit or other important mineral that results to that kind of issues? That's my question, is based on how can you combine security issues and trying to get a sample from that kind of place to analyze?
Your question is, anyway, if I understand your question, that is your place. One, you need to understand the geology. As a geologist, like I talked about the geology of what we are looking for, you first of all need to know whether you don't just need to go to a place and not picking sample. Like when I started with some techniques, exploration techniques. Before you go to a place, if you want me to explore Maiduguri or Sambisa Forest, for example, I won't just carry my car, move inside Sambisa Forest to go and obtain sample. In short, before I'll go to any location to get a sample, I must have done everything possible to say 50% this thing is there.
Yes.
My geology must have told me that it's there. My remote sensing must have told me, my hyperspectral work must have told me, everything must have told me, and I am going to a particular location with targets generated. That is how I started with it. Your area you're talking, you ask yourself, even without is there any record of it before? If there's no record, what is the geology we are talking? Is it within the para-alkaline ring complexes, or is it within the plateau complex? Is it within granitic zones? Is it within the pegmatic zones? Is it within? So you need to ask yourself, the geology, does it warrant that? If the geology is telling you that, what have you done on your own as the geologist to take a risk? Because if you know it is there, you want to go and take sample, it's not a problem. If you told me that the place now there is a rare element and we are going to go there, who is there? Who is pursuing you there? Is it not a human being? What does the person have? If he has 1 AK, you come with 10 AKs. We've gone to walk in a place that where we walk, we saw people with guns in the bush, and they could not attack us because we came with more numbers than them. We only greeted ourselves. We told them we are not here for you guys. They told us they are not here for us. And we moved in, did all the whole work. They even guided us, and we left. Do you understand? We've gone to another place where we got to, we saw the guy, we told him, no, don't run with his gun. We say we are not here for you. We are here to do our business. So that is the nature of it. No, it's not an issue of you trying to go and risk a place or because they said there's an insecurity somewhere. Then you not tell me because there's a rare element, that's why there's insecurity. Who told you there's insecurity? Is it the local that will come and know what is the rare element to start fighting over it? In short, let me tell you, even if there's a rare element in any most of the locality, they wouldn't even know what to do with it. It's just like you, let me tell you, some people will have diamond in their hand, they don't even know what to do with it, where to sell it, how to go about it. They wouldn't even know what it takes. You know, so like I said, if you are sure of something somewhere, there are ways of going to places where you don't have good security. Even in Abuja now, everywhere they go with security. Everybody moves around with security anywhere now. So that's why we don't have policemen and this thing going, doing the right job everywhere. So you share the security among the big people and everything. Thing don't finish.
Thank you, Doctor. Thank you, Jacob.
Thank you.
Let's just take a last question before we round up. Someone asked on the chat, I need more explanation on the difference between rare metals like lithium and tantalum and as against rare earth elements. Rare metals.
Lithium is not a rare element. Lithium is not part of it. Tantalum, they are not part of it. These are metals.
We call them rare metals.
If you look at rare element, is actually defined if you follow that. Rare elements are a group of minerals. These are a group of elements, actually, but there are 17 of them with some specific, you cannot group. We are Nigeria because we are in the same geopolitical zone. We have the same color, we think alike, we have the same this and all. You understand? That's why we are Nigerians. We are not Chinese. Chinese is in their own zone, in a different continent. We are grouped as one. And in Nigeria, we are grouped as what? States. In states, we are still grouped as local government. In local government, we are still grouped as world. Is that not true? The more you go further, the more the differences increases. So the same thing. So rare elements, like I said, they are not really rare in terms of you don't see them. They are there, but the concentrations are very small. You know, they are very, very minute compared to lithium. Lithium are measured in tons and all that. You can mine lithium, you can mine 30, you can mine 1 truck of lithium in one day. But you dare not try that in rare elements. You can't say you mine 1 truck of gold. Do you understand?
Of course not.
Yeah, so they are different. They are not, you can get tantalite. They are not the same price at all. You don't look at them, they are not even the same price. So they have some basic characteristics that enables them to be used in the modern technology. That's why they are called rare elements. So that's what so the new technology that are coming out, most of the things, electronics, most of the lasers, most of the EVs and everything, this is most of them, the components are built with this strategic mineral. So that's why they are just costly than any other metals.
Thank you so much, Doctor. Thank you for the eye-opening presentation on rare earth elements. I think a link will be posted subsequently so that you can go through what has been presented.
Okay, ask Abigail whether she has any announcements too.
Abigail, do you have any announcements before we invite Dr. Falau to give us a closing remark?
No, sir, there's no announcement.
Okay, you send it on the listing. Okay, sent on the platforms and all that. Okay, that's good. Are you sure Madam is still around? I'm not seeing her here. Okay, she's still there.
I'm there.
Yes, she is. Please, ma'am, can you give me very much?
I appreciate you all. May I take this time to appreciate some very professors of professors, the doctor of doctors, no other person than Dr. Mrs. Oyenike Shaulawa and Professor Mada. Thank you for being with us from the beginning to the end. We appreciate you. These are the kind of people that we want to be part of us so that we can groom this new generation, upcoming new generation. Thank you. Our webinar program is the last Wednesday of the month, and we have always been making it without breaks. But there's one thing particularly about this webinar. We want it for the young ones, and most of them are always busy. Busy doing what? Busy doing what they don't know how to do. Yes, I will say that for those of you that are here, please encourage them to be part of us, because there's one thing we all been talking about, and that is advocacy on our mineral resources in Nigeria. Most often, they don't even know the rocks, the host rock to look for in sourcing for certain minerals. When all these are not known, you just be wandering in the bush without knowing what exactly to look for. I'm saying that, please, that's why when we started, I was looking for all the representatives, state by state, in the AMEG group. Please, it's part of what we need to do. We are doing it for sustainability, not for individual gains. When the sector is sustained, development will come in. And that is when our money, the money we're looking for, will now follow. Thank you very much, because we need to come and collaborate. Collaboration is not just in geology, even with bale, that's sweeper in the mines, we have to collaborate with them, because most of the dust in some cases even contain more money than the rocks itself. You can see what is going on in the granite industry now. Everything has become money, no dust, no more dust. So I'm taking this opportunity to thank everybody and to say that we should not be tired of whatever we're doing. The future is now, and we have to be very, very committed to whatever we're doing. God bless us all. See you next month, same time. And
okay, Ma. Thank you. I think that Dave, there's somebody that is one of the gurus of rare elements here.
Oh, really?
That is, I just saw his name. I don't know. Christopher the Bong is here, and he did anything, and I needed to drag him to make 30 seconds.
He'll come
30 seconds comment if he can actually hear me. He has done so much work on monazite and all that, which I'm aware, and he has done a lot of testing also. So, Christopher, you are hereby declared.
Yes, my boss.
Okay.
Christopher, you are trying to hide.
Thank you very much, Dr. Gideon. In fact, you have said everything. There's nothing there for me to say. Just that there's a lot in Nigeria that we are still scratching on the surface, and we actually need a structure and a system for us to actually pull this through. There are a lot of states in Nigeria now currently that are moving to Niger State because of monazite, and there are a lot of them. And interestingly, in Nigeria, everybody's just looking at monazite, the alluvial, but we should also take into consideration that monazite also exists as art rock. And I think I will also have a discussion with Gideon on that. There's also an art rock of monazite, but it's not commercially viable. Like, people don't buy it, and the reason is simple. It does not contain thorium. The thorium in those art rock is like 0%, and I think, but the Chinese are actually interested inside of the thorium that is inside the monazite, and it has a large deposit. The true content, the total rare earth oxide content, is the same thing as that of the alluvial, but it does not have economic sense. But we can actually extract the lanthanum, the cerium, the prasinodium, and the niobium. We can actually extract from it. So there are a lot of things can be done in the rare earths sector, and I think we are also moving on the right path. God will help us. Thank you very much, Gideon.
Thank you. I appreciate that, your contribution so much, Christopher. Thank you. Okay, Dave, I think you need to let me see if there is. We need to let them new faces. You need to actually also recognize today for also joining us. I think it's a nice one who come in. I will thank everyone. Like Madam said, this one is in the bush. I don't know what he's doing actually. Yes. He's here today. He's also here. I will thank you. Professor Joseph Amanda, thank you, sir, for coming. I appreciate your presence. Gabriel always will be here, but he will not talk. Jayola is here. He's not talking. Emmanuel Benjamin. Okay. I thank everyone. I think that's fine. We can put your Fadele is even here. He didn't make any statements. These are people that have actually, you know, that we can, you know, these are people that the industry are looking out for. And they will come for a webinar instead of them to come out and tell people what they've experienced so that people will learn from them. They keep keeping it won't make you grow. So tell us, you know, this kind of thing contributes to what I know most of you have worked in some projects, you know, at least give us the hope that these things are there, that we need to go further. I think that's fine. Okay, we can put our videos down, take our pictures, and then we can actually close.
For any responsible mining, no waste.
Mine say what?
For any responsible mining,
yes,
no waste.
No waste. Yeah. Okay, put your video. Yeah.
They said monazite in the alluvia, but the one in the primary are not economically. No, just leave it. It's a matter of time. They will look for that too.
Put your video on. Yeah. Okay. Well, we come back one day. Okay, this is fine. Okay, that's fine. Dave, I'm true. So
thank you very much.
Thank you so much, everyone. We'll do this again same time. Last Wednesday.
I think next month is Christopher. It's Christopher that is actually going to talk to us next month. I think.
Doctor.
Yeah.
I think we need to do more expose on the REEs.
Yeah.
Because we're beginning to have more interest in them in Nigeria. More companies are coming in. Let's do some more research and find something to present so that people can be scored on in that.
I think we need more on exploration clues. We can like today, yes, for example, exactly. We did not deep. You know, these things are so each part of it is so. If we discuss only the geochemistry of REEs, we will not even finish it for 1 year.
Yes.
If we want to bring in, like, if you look at the exploration techniques we brought in there, one is geochemistry, one is geophysics, aerogeometric, and if you pick one of it, we cannot even finish. It's so much that we need to. So that's why, you know, constantly we need, so that the geologists will understand that these things are there and the way forward, because we're trying to build capacity. I have found out that most of our young geologists are eager to make a lot of noise, but they don't understand what it entails to be successful in exploration. You understand? It requires a lot of discipline. It requires a lot of training. That you carry GPX and go to field and pick points and come and plot map doesn't make you a geologist. It's not. That's not it. Not what it takes. In short, I don't want to go there now, but you know, we need to go, you know, gradually from time to time, you know.
Time is fast spent. Thank you so much, everyone.
You're welcome.
Okay. Bye.
Thank you. We appreciate you. Bye.